In terms of blank end plugs, a good blank end plug design needs to provide really good sealing integrity to the feed end permeate tube, but it also must expose maximum area, feed channel area, for the feed to make its way through into that feed channel. As with an ATD, the end plug itself must be able to effectively clean in and around that seal and having good access for fluid through to that area. Otherwise it'll create quality issues in the plant, as with a poor cleaning ATD core. So we come across some designs or some plugs that just have zero access for CIP fluids. So this is one design here, a plug type design that has it's just a straight plug with no channel or no bevel to allow any sort of fluid in and around this area at all. We've got the seal and then a big hunk of stainless steel, no access for fluid. Let's look at what that looks like directly in a permeate tube. First, the O-ring type blank end plug. As you can see, there is no recess or ability for cleaning fluid to enter at any great velocity to clean this space between the seal face and the O-ring. So product and water may ingress slowly during production up until the seal face. However, the cleaning fluid has no path to adequately clean any of this area whatsoever, pretty much rendering this blank end plug design unhygienic. You can also see very limited seal contact area against the wall of the polysulfone permeate tube, and that's the sole barrier for reducing or stopping product from entering this permeate tube directly from the feed side into the permeate tube itself. When we look at the SMS lip seal blank end plug, we see a large difference. Here, the blank end plug allows for full CIP flow to enter all areas around the face of the lip seal, therefore providing a full hygienic design. And when we look at the sealing area comparative to the O-ring blank end plug, we now have 3 to 4 times the sealing area or protection, thereby reducing risk of any product transfer from the feed side of the blank end plug into the permeate tube. Here's another example of what's called a blank end ATD used as an end plug. Now some customers do have to use the blank end, so it has the seal on one side and blank on the other. Some customers do have to use the blank end ATD because they are very restricted in room on the feed end of the vessel, and they just simply wouldn't have the room for an extended plug of the nature that we use. But in a lot of other cases, there is a blank end type ATD plug used in plants, and there's just not that requirement there because you are starting the vessel with some limitation of the wheel spokes when it's absolutely not required. You just need to seal the permeate end of the vessel. There's no telescopic forces in play down this end of the feed end of the membrane, therefore no ATD requirements. So that's a brief overview of ATDs and end plugs. Smart Membrane Solutions can advise on all facets of your membrane accessories, so if you should have any questions surrounding your plant accessories or components, please feel free to reach out to us and we'll be more than happy to help.